Alright, so we are going to wrap up 1.1 today. I'm going to kind of modify a little bit of what you're doing in this section with problems 1 through 10. Okay, we're just going to do them as scatter plots and graph them, basically, and then find the best fitting line to go with them. And basically, that's all we're going to do with that. So, just starting with number 2. Okay, we have the table. It's got the x values and y values. And you won't have to copy the table over when you're doing your homework. I'm just doing it so that we have it here to refer to while we're doing the problem. Okay, so do you guys remember how to input stuff in lists in your calculator? Nope. You hit stat, hit the stat button, then hit edit, and then those of you in stats probably have like 40-some numbers in list 1. You might want to go clear that before you, yeah, we're done with that problem. So I'm going to clear mine really quick. All right. Yeah, so the y values will go in list 2, x values in list 1. So basically we're going to be drawing the scatter plot from your calculator. And then finding the best fitting line. Okay, or possibly the curve as it may be. Alright, so once you do that, okay, you're going to hit second, stat plot. Make sure your plot is on to the right type. Scatter plot. The first one. What? What part? You have to hit stat, and then the first option is edit, and you want to type your numbers into the list. Alright, so once you're over here, you're going to hit zoom 9. Make sure you don't have anything in your y equals. Okay, and when you do that, basically we just want to copy it over from our calculator with what it looks like. Do what? Zoom 9. Do what? What do you mean? They're like points, like XY points on the graph. I'm going to show you in just a second. Huh? At a time, yeah. Unless you turn that plot off and then go turn another plot on. Yeah. No, because you wouldn't know what points go with what. I mean, y'all's might, but mine won't. Mine's all in one color. Alright, so the way I got the line, okay, and I'm going to tell you the lines. So basically, in these problems, you're supposed to match it with what the graph looks like, and you're supposed to say what equation of the line from the book goes with it, or of the quadratic, whatever. This one's quadratic, obviously, you can tell. But I'm not going to have you guys doing these ones that are quadratic. Okay, I'm going to give you ones that are only lines, but I'm going to show you how I got the quadratic just so you're familiar with it in case. And you do the same thing for when you're finding a line. I'll just show you the other one that we would use. Let me focus this so that you can actually see the buttons. They are sparkly. Well, two of them are. Alright, so to do this, we're going to hit Stat, arrow 1 to the right to Calc. Now, the one that we use and that you're going to be using is this linreg, okay, and it gives you an equation of a line in the form y equals ax plus b, okay, a being slope, b being your intercept. Okay, that's the one you're going to be using for the problems I give you. But this one is quadratic in nature, okay, you could tell that by just the way that the plots, or the dots kind of go up, I mean like a parabola like we've seen before. So that means I need this one that's quadratic. So I hit enter, and it should have everything for me. But then I want to store it in, like, let's say y1. So I'm going to hit alpha, trace, and then I'm going to pick, excuse me, my y that I want it in. And it's going to store it there. And then I'm going to hit calculate. Okay, so in this case, and this formula doesn't match up exactly to the book because the book has done an approximation of it. Okay, so we would find this is going to actually be a best fitting curve in this case. Okay, and this one we would write as x squared plus 1.3 times 10 to the negative 12 x plus 2. Okay, that would be the equation of the line, or of the parabola, okay, that you would have. I'm not going to require you to do the quadratic ones. I'm going to pick the ones that are linear. Okay, so we're going to go and do a linear one really quick. Not second, just stat, and then calc, and then the number 5. Because we want the equation to be there so it'll graph it. I just hit graph again. Okay. Alright, did we all get the curve? Alright, so number 6, I'm not going to copy it over. You can look at it in your book. Okay. We're going to do the same thing with this one. This one is going to be how I expect your homework to be done. So once you get there, it's on page 75. You're going to type in the numbers. Oh yeah, you should have your book out. That's what I said to have, actually. 75. You need to make sure you turn off or you go clear your y equals also. Okay, so you would copy that over to your paper exactly as you see it on your calculator. So now, once you have that, you want to find the best fit line, so you're going to hit Stat, Calc. You're looking for linreg, which is number 4. Store it in y equals by hitting alpha trace. And then I get the curve, or the line, y is equal to 2x plus 3. Alpha and then trace. You have the wrong form then. I said to use linreg, which was number 4. Well, then yours should have 0 for A, and it should have 2 for B, and 3 for C. Well, as long as it has that, just don't write down the first x squared term, because it should be a line. You should be using linreg. It's warm. Alright, so that's all for those. Okay, I'm going to give you a couple of those that are linear for you to do. So looking at 11 through 18, okay, it says to use the table that shows the percentages of female and male populations in the United States employed in civilian workforce in selected years from 1954 to 2004. We're going to look at number 12 to start with. And 12A says, according to the numerical model, what has been the trend in males joining the workforce since 1954? Nope, you don't have to enter anything. Don't need your calculator at all. Just looking at the chart. You're looking at male, right? Okay, it's decreasing every year, except for a slight increase from 1994 to 1999. B, in what 5-year interval did the percentage of men who were employed change the most? So you're basically looking for where is the biggest change that occurs. Hold on. So I would check those intervals y'all are saying because I don't think anybody said the one that it's actually supposed to be yet. There's an interval with a bigger drop than y'all have said. Are y'all ready for a quiz over there in the corner? Okay, are you looking at the problem that I'm asking about? Any of you? Yes. Okay, it's 1979 to 1984. Let's see. Alright, so look at 16 for a minute. Okay, we're not actually going to do it because I'm going to have you guys do it in your homework, but I'm going to explain what you need to do. Okay, so 15 says to model the data algebraically with linear equations of the form, blah, blah, blah. Write an equation for the women's data and another for the men's data using the years. So basically you're going to have to make two separate plots. Okay, you're going to do two individual ones. The X list is going to stay the same. It's going to be the years. The Y list is going to be the female for the first one, male for the second one. Okay, you want to get that linear regression line from that. Okay, so you're going to do the stat plot. You're going to have two separate stat plots for that problem. Then you're going to find the linear regression line. And then what you're going to do then in problem 16 is you're going to take that linear regression line and you're going to plug in 2009 for X. And you're going to see what the value should be for women and what the value should be for men. Okay? Does that make sense? Okay. Then we're going to do one more of those problems like we did yesterday, okay, about cake. And then I'm going to give you all time to work. Huh? So we're looking at problem 20. Alright. A bakery sells a 9 by 13 inch cake for the same price as an 8 inch diameter round cake. If the round cake is twice the height of the rectangular cake, which option gives the most cake for the money. Okay? So we have a 9 by 13 cake, and then we have an 8-inch round cake that is 2 times the thickness. Okay? So we want to see what is the best option for the money. So, how would I find the area of my rectangular cake? Nine times 13, which is what? 117. What is the area of a circle? What did you say? Pi r squared. Okay, which is equal to pi times 8 squared. I did that intentionally. We'll see if you'd catch it. Yes. Okay. Yes, I'll give you a cookie point because I did it intentionally, but I will give you a cookie point because you caught it. I didn't have to correct it. Well, it was an intentional mistake because I wanted to see if y'all would catch it. But it's an 8-inch round cake, meaning that's the diameter of it. But when I do the area of a circle, I need radius. So, since you caught it, I'll give you one. Even though I did it on purpose. That's why I looked at you. So which cake's the better one for the money? You sure? What is that? Wouldn't it be like 100.6? Oh, I guess you used whatever number was already there. You didn't use the, okay. Okay, so the best cake for the money is the rectangular cake. Okay, those make sense. Make sure you do pay attention to if I give you diameter or radius. Okay, last year I stumped the class by changing some stuff on it that was the same problem that we had in class, but I modified it a little bit. And yeah, I haven't looked at that problem yet. I was seeing, well, I intentionally left that to see how y'all would do with it. It might be an extra credit problem. Alright. Any questions about these, though? Okay, let me get you guys some problems, and then see what I can do with your time. And then you just had to make sure that the distance is between each vertex and the hypotenuse. Technically, you didn't actually have to do the distance of all the sides. You only needed to do the distance of the hypotenuse side, and then you just needed to do the midpoint of that. And then, technically, you didn't have to do that. You don't have to do the distance of that. You just needed the midpoint of that one, and then you needed the distance from each vertex. Alright, there's your problems.